Could we go over like the video talked about shell sorting or shell insertion and how it was like way more efficient.
Yeah.
I kind of like struggled understanding exactly how it was so much more efficient, especially compared to like linear because it uses linear,
Yep.
and I figured it'll eventually use linear on every element. So like why is it that much better?
Yeah. That's a good question. And I'm just looking at my slides really quick because there are some sorts that the video goes over that we aren't going to cover, but there are some that we are going to cover, and so I just want to check. Yeah, so we're going to talk deeper about shell sort on I think next time. I'm pulling up my slides really quick. Uh-oh. You're getting a sneak peek. Oh, no we don't because I shifted things around. No, I'm just going to tell you right now. I'll cover insertion sort and shell sort on Wednesday. So I'll get deeper into it. We can certainly get into it now, but at the same time, I don't want to steal too much of my thunder from Wednesday. The the video is a little. It does things in a little bit different order, which is why some of the sorts I had you guys watch we haven't talked about. But as we get through this week, we'll come back. Is that okay?
Yeah, that's fine.
I'm kind of refusing to answer your question, but I'm letting you know that I'll get
Uh,
to it. Yeah, I'll cover it.
yeah, that's good.
Cool. Okay. Man, it's my favorite video. It's what YouTube is made for. Is that kind of video. Other questions on sorting, in particular selection bubble sort? Had you guys seen bubble sort before?
I think I used it in CS2 once.
Intentionally or unintentionally?
I think unintentionally.
Yeah, that's most of the time that's how bubble sort ends up coming up is people don't really think too much about it and then accidental bubble sort. Cool. Okay. I mean, if you guys feel good about it, we can talk about whatever you want.
I think my biggest question from that lecture is if bubble sort is so terrible,
Mm-hmm.
then why do we want to learn about it specifically?
Yeah, that's actually yeah, that's a good question. And what we're gonna get into in this whole lecture is that at the end of the day, quicksort is aptly named because it is quick, and for the most part, you'll just always use quicksort. It turns out that that's not. It turns out that it's complicated and it's complicated. One of the oh man, I should have looked that up now. There's a pretty great website that actually goes through and does like side by side comparisons of different sorts, and it's really useful. I'll find that link before Wednesday and send it out to you guys. Quicksort isn't always the best. Most of the time it's the best, but not always. But we'll see this on Friday when we talk about it. Oh, is this it? This is it. Awesome, good. Right. So this is the website. Thank you, Zach, for pulling this one up. So the cool thing about this site is that it's showing you. Let's see if I can make it bigger. Thank you. It's showing us both best case, worst case, and then kind of similar type sets for different sorts. So for example, like bubble sort, I can play each animation and it'll go through and run this animation of us bubbling up through our array, right? So that's going to be our random starting set. The few unique, just to define what it's doing, is it has a lot of elements that are the same value. So I think there's like four. It looks like four different values, but they're all over the place, right? And then reversed and nearly sorted are both going to be essentially best case or worst case for some of them. So it turns out bubble sort is just kind of terrible all around because it's going to end up doing, well, except for nearly sorted, it's going to end up doing all the same operations regardless of the randomness or the not randomness of the sort. Our selection sort is going to be, oh, go away. I don't want, there we go. Right, we can go through and see our selection sort is also equally as terrible. It's just not helpful. But if we go through and play like a quick sort, one of the things about quick sort is that you end up parsing out your sorting method basically into small chunks and then have only the small chunks do the sorting. And so it's a really good divide and conquer algorithm. But what we'll see on Friday, which is when we're going to cover quicksort, the algorithm is a lot more complicated. There's a lot more going on in quicksort. There's a lot more things that can go wrong. But if we flip back to these kind of high level algorithms for selection sort and quicksort especially, where we got, it's down here at the end. I know this is a slide heavy presentation with all the animation, right? There we go. Like our quicksort algorithm is as simple as we can possibly get. Right? There's not much more we can pare out of a sorting algorithm to make it less code. Now, an easy retort to that is like, well, Scott, why does the lines of code matter? It doesn't. It just happens to be the bubble sort is extremely straightforward to code. That's why it kind of bubbles up in CS2 is because it's pretty intuitive how it works, and it seems pretty good at the start until you start thinking about how many exchanges it's doing. But on Friday we'll get into quicksort. Quicksort isn't terrible, but it's also not nearly as intuitive of, hey, just keep iterating over your thing until it's sorted, which is basically what bubble sort is. Insertion sort or selection sort is even more straightforward, right? Find the smallest thing and then put it in its place. Find the next smallest thing, put that in its place, right? Keep going. So, right, the kind of the longer answer to why do we have a whole week dedicated to sorting when really you're probably only going to use one sort in your life is because it's important to know the nuances. Same thing with containers. You're probably not going to use that many, sets in your life as a programmer, right? Some of you will get to the point where that will make a lot of sense and it'll be very good for your application. But for the most part, a lot of the things that we cover in this class are much more theoretical than like CS1, CS2, where like you're gonna use pointers, you're gonna use file input output. But data structures, it's a little more, we want you to be able to think critically about these different things. And so this is an example of, well, yeah, it's important to know why bubble sort is bad. But you're right, you're not gonna ever use bubble sort. The point is to get at and to express this idea that different sorts are gonna take different time. Yeah. Is that satisfying in any way? Does that help?
Yeah.
Okay. Yeah. And your intuition is not necessarily wrong. Like it is kind of frustrating to just be like, wait, why am I gonna have to learn 7 different sort algorithms, but only one of them I'm gonna use? Yeah. Well, because it's kind of like I talk to Gwen about this all the time about like you have to know good art techniques before you can break them, because if you just break art techniques, you don't know what you're doing, right? It's kind of that like you need to know the context before you can break the context. Cool. Okay. Questions on sorts? Other thoughts? Other concerns? I know that I haven't posted it yet. My goal is to post it by the end of today. The last project, Project 7, is basically going to be, I think I'm just going to have you guys do 3 or 4. I haven't decided yet. I think it'll be 4. Just make 4 different sorts and then compare them similar to how you did like exam 2 practical, and just make a testing framework for your sorts and just see what happens. Basically do kind of like this website, but with your own sorts, and see what kind of information you can get from there. Again, the goal on both projects 6 and 7 is not to be overly complicated, more just to reinforce the concept. So don't stress too much about that. I hope you guys all saw final project stuff. I pushed that information out to your guys' WikGit projects. If you want to start working on that, you can. Next week, as a heads up, I think I have 1 lecture planned for Monday, but I don't think I'm actually going to spend that much time into it. We'll do essentially like a review for exam 4, which will be Wednesday, and then that's it. Right? Basically, all we've got left is like 2 more lectures on sorts. We've got the 4th exam, and then we've got final project stuff. I just want to make sure you guys are all aware of the kind of timeline for the last couple weeks.
Scott, when would you like us to let you know about final project partnerships and stuff like that?
Today. The deadline
Okay.
the deadline was yesterday, but I'm okay with today since I didn't have a chance to talk about it in class. So yeah,
Okay.
go ahead and talk with your partner and email me by the end of today, and I'll set you up a group project in WikGit, so you can both access the same code. But yeah, that would be beneficial to
Okay.
do it sooner than later.
Okay.
Any questions on final project stuff or on like the hash project?
So I have a question on the templated iterator. So I saw that a question was asked about it in the chat,
Yeah.
but I'm still just kind of curious. So what does so if we're looking at Ethan's picture he sent,
Yep.
so he put type name before the iterator,
Yep.
um, which I guess makes sense. It's just weird. But then what I don't understand is why is it changed to a constant iterator now?
Oh,
Because
so it
all other times we've just used a normal iterator.
yeah, so the difference between an iterator and a const iterator is that your const iterator is going to protect the constness of a thing. Now, that's a lot of words. So let me explain why it matters. The insert shouldn't the iterator that you get back shouldn't necessarily change anything inside. That's why it's a const iterator. Remember that const is a tool that we as developers can use to protect the structures that we develop. So
Hmm.
a const iterator is simply one that does not change, right? It essentially is like a quasi pointer, but it's not quite a quasi. It's not quite a pointer because you are protecting the data structure that it may or may not be inside of. Similar again to like a linked list where we had an iterator that was protecting the idea of a node. The external to the class didn't know what a node was, but you could still use the iterator to then access the information inside the node.
Yes.
So in a similar way,
Um,
this iterator to a list is going to allow us to get access to the data inside the item. Really, it's going to get us to the pair. Yeah, you could use an iterator. That's okay. I don't want to get too sidetracked in which one you should use.
Okay. So I'm just trying to understand a constant iterator. If I was to set, or let's say I wanted to, what's it called? Like iterate through something starting with the constant iterator, could I do like plus plus on the iterator, or does the const prevent that?
Oh man, my mind's blank right now. Let's find out. I honestly don't remember off the top of my head. We're getting at C++11. We want constant. It says a bidirectional iterator, const value type. Yeah, that's what I thought. So yeah, you should be able to move a const iterator. It's just
Okay.
that the thing that it
Cool.
is pointing to cannot change. So that's similar to like a const pointer, where the pointer value can change, but the thing that the pointer is pointing to cannot change.
Okay.
And I know that that's almost cyclical in nature, right? Like we're getting close to this idea of it is a thing that is a thing that's a thing, right? I know that's
Yeah.
not very helpful, but it's and this is part of the reason why I'm not going to enforce you to use constant iterator. Ethan is using it, which is fine. That's a good use of a constant iterator in his example, but I'm not going to make you guys do that. That's fine. I care more about you
Okay.
dealing with the hash function and how to do the insert and remove there, as opposed to the minutia around const iterators.
Okay. And then for the pair struct that you provided us with,
Uh-huh.
would that be the same as if we used standard pair with string and then type?
Yeah, I think so. I'm trying to recall. I wrote that last year, and it's based off of the pair from the book. But the standard template library pair is very similar. Actually, let's look it up before I.
I'm not going to use it. I was just curious.
Yeah, I think it's very similar. And the only reason I just want to look at what they have: swap, relational operators, swap, and get. Yeah. It just says first, second type. Yeah. The one benefit. No, it's basically the same. Yeah.
Cool.
Yep. Cool. Okay. Other questions on project 6. Don't overthink that one, right? The hard part is the hashing function and how you deal with the hashing function. Don't get too caught up in list and vector stuff, right? That should be pretty straightforward. If you're having an issue with it, that's fine. We can figure that out. But I'm just saying, don't make that one more complicated than you have to make it. Cool. Okay. Yeah, I mean, unless you guys got more questions, I don't necessarily have an agenda for today. I know today's pretty light in terms of content. It's just the 2 types or the 2 sorts. By Friday, we'll get into a comparison between all of the sorts, and that'll get a little more interesting and complicated. But yeah. All right. Well, unless anyone has any last thoughts or questions or concerns, we can call this one good. Nice, short, and sweet. I'll be around for a little bit if people have questions or comments or want to talk about stuff. You guys are good to go?
Thanks, Scott.
Absolutely.
Thank you, Scott.
Absolutely.
Thank you.
Cool. We'll see you Wednesday.